Okay, good morning, everybody. I'm Sindhil. I'm from HPE, and I am the technical product manager and storage solutions architect for the SMB, small and medium business unit of HPE. So today, the intent of the talk is to give an overview about the software-defined storage and how HPE and Microsoft is coming together and provide you a solution on the software-defined storage. Before we start, I just want to give an overview about why software-defined storage and how is it better than the traditional SAN, right? So one of the biggest questions people have is why software-defined storage? Why not the traditional SAN, right? So the software-defined storage. So let's look at a traditional SAN, for example. So in a traditional SAN, you'll have one or more servers connected to a SAN array. So either you can direct connect that with an iSCSI direct attached cable, like in this case, and or you can put a switch in between and connect multiple servers to multiple SAN arrays, right? So let's take a simple example in this case where you have two servers connected to an SAN array and using a direct attached cable. And let's say you are running out of capacity, right? So before that, I just want to highlight what are the features and what are the disadvantages of the traditional SAN. So in the traditional SAN, everything is hardware controlled, right? So it's a hardware controlled RAID. So you want RAID 0, RAID 1, RAID 5, RAID 6, RAID 10. Everything is hardware controlled, right? So that's one point. The other one is hardware controlled storage features. So for example, if you have like read cache, write cache, or automatic data tiering. So when I say automatic data tiering, it's like based on your hot and cold access to the pages, the data automatically resides in the SSD or resides in the SAS or in the SATA based on the access rate of the data, right? So that's called automatic data tiering. So that feature is again hardware controlled. Similarly, if you want replication, that's again hardware controlled. So everything is hardware controlled in a traditional SAN, right? And if you're running out of capacity, what you're supposed to do, you will be throwing in disks into the SAN enclosure, right? So if you can run out of capacity, you'll keep adding, but at one point, you'll hit the case where disk slots are full. So what do? You cannot do anything. So the next thing you have to do is you have to buy one more SAN array and then connect it via a switch to the servers, right? So that's how you scale out, right? So you cannot, once the slots are full, you're limited by the chassis capacity, and therefore you have to like buy another array, which is expensive. And of course, a switch too. So just to summarize, the problem with the traditional SAN is arrays can only scale up, right? They cannot scale out. They can only scale up. Scale out requires additional arrays and switches, which are very expensive. I mean, it's like almost double the price of a software-defined storage. It's hardware controlled. So which means it's difficult to manage. You have to like upgrade firmware. You have to upgrade everything in your controllers. It's very difficult to manage. And it's not all in one solution, as you can see. We have like servers, we have switches, we have like arrays, which could be multiple vendors, and therefore it can get pretty vendor specific very quickly. So that's the next point, vendor specific. And then it's very difficult to configure and upgrade. You have to create zones. You have to configure the controller to do whatever you want to do. So it's like a much difficult exercise. So what is the solution for all the problems I just mentioned now? So the solution is the software-defined storage. So what is software-defined storage? A software-defined storage is nothing but you start with at least two servers and use the drives that are internal to the server, and then you build a virtual SAN out of it, right? So you buy two industry standard servers, you throw in an 10 gigabytes Ethernet in between, and then you create a software-based cluster of the two node, and then you can create a storage pool using the internal drives of the two servers. So let's say if you have like DL380, HP proliant DL380 server with internal drives, if you buy two of them, you basically get 24 times 2, like 48 drives. So you can create a storage pool out of the 48 drives, and then you can create a storage pool, and then you can start carving out volumes, LUNs, as you do in a storage array, in a SAN. So except the only difference is there is no array there. You are purely building a virtual SAN using the internal disks and using a software-based cluster, right? So what if you're going to run out of capacity? If you're going to run out of capacity, you can throw more disks into the server, into the internal slots. You can, of course, do it on the server number 2. And if the disk slots are full, what do? You simply add another server onto the same 10 gigabytes network, and then the cluster will automatically scale out. So with the Microsoft Windows Server 2019, when you throw in a new server, the Windows Server 2019 will automatically assimilate the new server and the disks that are within that, and then automatically it stretches your volumes to the new node. So that's the software defined. So just to summarize, what are the various advantages of software defined storage? So basically, the control plane is separated from the data plane, right? I mean the data plane. I mean in a SAN array, it's everything in one, right? The control and the data is in the enclosure, whereas here the control plane is separated out to the software layer, and the data plane is at the internal server layer, right? And the horizontal scale-out model is not a scale-up, but a scale-out. So you can keep throwing more servers, and also you can if your network can stretch, you can pretty much have the new server in a different site as well, right? So it's like disaster recovery kind of comes in naturally because it's a horizontal scale-out, and it's all software defined and controlled now as opposed to the hardware, which means that it's much easier to configure and update. So some of the key things that I would like to highlight in the Microsoft Windows Server 2019 storage spaces direct, or the Azure Stack HCI if it's qualified, is the resiliency. So Windows Server 2019 supports all these types of resiliency. So it supports two-way mirror, which is kind of like RAID 1, which means that your data is stored on one node and a copy is stored on another node, right? So that's like a RAID 1, but a software level RAID 1. So that's a two-way mirror. So you need, of course, at least 2 nodes in the cluster for that. You have three-way mirror support, which means if you have at least 3 nodes in the cluster, you keep data and a copy on server 2 and server 3. So that's a three-way mirror. So of course, the efficiency of the two-way mirror is 50%, because if you have 2 terabyte, you only get 1 terabyte usable capacity. And if it's a three-way mirror, is 33%, because you get 1/3 of the capacity. And dual parity, that's another one. So dual parity is basically you keep data on node 1, data on node 2, but parity 1 and parity 2 on node 3 and node 4. So it's like kind of like RAID 6, but not exactly RAID 6, but a similar concept. So the dual parity gets you more efficiency, and it requires at least 4 nodes. But of course, the compute intensive nature of the parity is there, because parity requires CPU cycles to compute the parity, and it's a little bit more slower. So dual parity is more recommended for archival, backup, and those kind of applications, whereas two-way mirror and three-way mirror is more recommended for databases and virtualization, where you demand performance, right? So that's the thing. There's also nested resiliency. So nested resiliency is basically you keep data and a copy within a node, and then you keep a data and the copy of that in the other node. So it's like RAID 1 at the node level and the RAID 1 at the cluster level. It's just like, this is typically recommended for production things. So in case like, if one server goes down, and you are left with only one server, and if a disk on that server goes down, you are still protected, right? So the nested resiliency gives you protection with one node failure completely and one disk failure on the remaining node. So that's the nested resiliency. And similarly, you can get complicated nested resiliency. You can have like RAID 5 at the node level and RAID 1 at the cluster level, which means that you can have data parity within the node, and then exactly copy of that in the other node. So it's like RAID 5 within the node and RAID 1 at the cluster level. So that's nested resiliency. I have diagrams for it in case if you want to see that. It's in my backup slides. There is also auto-tied resiliency, which is mix and match thing. So this is recommended for like huge sequential bulk data writes, like backup. if you are like overnight, if you are like backing up like blocks of data overnight, which is sequential bulk write, what you can do is you can configure a two-way mirror area and a dual parity area. So which means that when the write comes in, it will first land in the two-way mirror area, which means there's going to be fast data injection. You can suck data much faster. But offline, overnight, it can move the data to a dual parity mode, which is more CPU intensive. So you get like more capacity. So it's like as you write into the software-defined storage cluster, it's sucking data at a much faster rate because it's a two-way mirror. So it's like large faster data injection. But overnight, it will slowly move the data into the dual parity area, which is CPU intensive, which is fine because it's happening when nobody is using the cluster, but it's going to gain capacity slowly, right? So that auto-tired resiliency is supported as well in Microsoft Windows Server 2019. Of course, deduplication and compression. So you can enable volume level deduplication and compression. So you can go to Windows Admin Console, WAC, and then you can click on the volume, and then you can say enable deduplication and compression. So which means if you are presenting that volume to an Hyper-V cluster, and let's say you are like 3 VMs using that volume, and if all 3 of them uses, let's say Ubuntu 18 dot something, there is only one copy of Ubuntu stored. I mean, I'm giving an example at a very, 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 very high level, but it's much more complicated. So basically, it uses the reference count model instead of copying the data again and again. So it will see that, oh, you know what, this block of data has this hash. So I have seen this earlier. So I'll just say increment the count, reference count. So your write speed is amazingly fast, right? So when you write, you're not actually writing. You're just incrementing a counter and then sending it, saying, write is done, right? So it's an amazing feature. But of course, the deduplication involves the calculation of the hash and inline. So it of course involves the CPU operations. Like every time you write, it's calculating something. So there is, of course, a CPU load at that point in time. But you are getting amazing write performance, and your storage capacity is saved a lot because you're not copying the data again and again and again, right? So deduplication and compression is recommended for, again, archival and backup kind of thing, because archival and backup, it's okay where the capacity is more important, right? Deduplication is more important, but CPU cycles, I can sacrifice that, right? Whereas for production, you don't want to enable deduplication because, like a database operations, like SQL Server, you are like reading and writing data at a fast speed. You don't want somebody sitting and interpreting the data and trying to deduplicate it, right? So deduplication compression is a great thing for archival and backup workloads. And Microsoft 2019 supports that at the volume level, and you can just go to the Windows Admin Console and then click on the cluster, click on the volume, and then just like a toggle button that enables it. So similarly, other interesting feature is auto data tiering. So if you have a server with mix and match of different types of drives, so let's say we have NVMe drive, SSD drive, you have like SAS and SATA, automatically Windows Server 2019 will use NVMe for your cache, for a read and write cache. And it will use the remaining drives for capacity. So when you're writing, the hot pages would be cached in the NVMe drives, and when for the actual capacity, the remaining drives are used. So this is like automatic, and you don't have to do anything, configure anything. This is automatic. So that's one of the automatic data tiering feature of the Windows Server 2019. And the spares, there is also this concept of spares. So for example, if you have like a total 128 terabyte disks within your 2-node cluster, it's recommended to keep one physical disk worth of capacity unused per node. So which means that if you have like 1.2 terabyte disk drives, so on a 2-node thing, it's better to keep 2.4 terabyte disk space as spare. Don't carve out volumes out of that. Keep it as spare. And the way it helps is, it basically lets the Windows to automatically repair a disk failure without having to replace it. For example, if one of the disks fails, you don't have to go rush to your vendor and buy another disk and go put it. You don't have to do it because of the spare. It will do the in-place repair on the spare while you can take your time to go and replace the failed disk, right? So that's, and since like we are keeping one spare disk per node, so that's again fault tolerant as well. So you can repair a disk failure on node 1 can be repaired in the spare on the server 2's disk, and then brought it back together. So those are the very quick summary of what the thing. So as you can see here, some of these features are not supported at even at a big SAN level. So this is like really at the software level you get like all the features of the hardware storage arrays. And it's future proofing. Of course, this is hyper-converged. This whole thing is hyper-converged. It's all in one, from all in one. So it's like you're future proofing it. And it's much cost effective. So I did a BOM using list price of HP, Proliant, and the Microsoft 2019. You can get a savings up to like 40 to 100%, depending on what kind of configuration you're looking at. So quickly move. So just to summarize, so basically, this is just what I just talked about. But basically, you can start putting in DL servers in your cluster. Install Windows Server 2019. Windows Server 2016 can also be installed, but 2019 is latest. And then you form a Windows Server 2019 cluster, and then you create a storage pool out of all the disks from all the 3 nodes. And then on top of that, you start carving out volumes, which is like fault tolerant, resiliency that I just talked about, highly available, and all the things. And then these volumes, you can use it for your VMs running on Hyper-V, or you can just use it as a scale-out file server. You can just use it like a file server, or you can use it like any other scale-out storage target, right? These are LUNs. You can use them as an AS if you want, just like, or you can use it as a scale-out file server, or you can use it for VMs, VHD files. So this is the sample configuration that I tested in the lab. So basically, it's a DL HPE Proliant DL server with 1 Xeon a processor, 64 GB RAM. Of course, I used 4 1.2 terabyte SAS drives for the capacity, and 2 480 GB SSD drive for the cache. And the cache is automatic. You don't have to do it. Microsoft will do it. And the 240 GB M.2 SSD for the OS. So one thing is you don't want to install the OS on the capacity drives. Microsoft recommends the OS traffic be separated from the data traffic. So you keep the OS in the different M.2 in the PCLE slot. So that's one. And then M.2 enablement kit so that you can go into the PCLE slot. And then, of course, the array controller we use is like E20i, which supports mixed mode. So obviously, you don't want the hardware array controller to do RAID because the software is going to do it. So you have to disable the storage controller to present the disk in the HBA mode, not in the RAID mode, because we don't want like hardware to mess around with the software RAID. So that's why that's a cheaper controller for that. And of course, the Ethernet 10 gigabytes network switch for the thing. So I know probably we're running out of time, but so how to install is just like you can install in 5 easy steps, and you can do that pretty much in less than 15 minutes to do the whole S2D. I mean, these are the 5 steps you have to do. Of course, I'm not including the installation of Windows Server 2019 itself, but once Windows Server 2019 is installed, these are the 5 steps. So you install the required Windows features using PowerShell. You create the cluster, you enable storage spaces direct, you create volumes, and if you want to scale out, you simply add node to a cluster, like we saw earlier, right? So, these are the PowerShell commands. So on one of the server, you just need to run this install Windows feature. That's a PowerShell command. And when you do it, it is going to enable all these features of the 2019 that are required for storage spaces direct. And so that will show the progress, and once it's done, the server will automatically reboot. And the next step you have to do is create the cluster. So you have to run that new cluster command with that simple parameters that a cluster would require. And so that's just an example. So once the cluster will be formed, and you can name a cluster, and you can assign an IP address for the cluster. That's what that is. And then enable storage spaces direct is just a simple command called enable storage spaces direct, right? It's very simple. So you run a PowerShell command, it's going to ask you a question, and you say yes, it'll enable it. And then you can see the storage pool. So basically, you're now seeing the disks from both the nodes on one server because it's a cluster. So now we can create a pool out of this with the spare I talked about. So you can create a storage pool, we can do all the things. And then once you're done, this command is going to make sure that your setup is all right. So this is a mandatory step. So you just run this test cluster, that the cluster you just formed. So this is going to test everything, and this will catch any issues if you have. And if it doesn't, then it will be, you're good to go if this step succeeds. And then you can create volumes. So to create a volume, you can just run that command, new volume, the pool name, and then the friendly name, and then the what type of file system. So for deduplication, you can use NTFS. But if you want to have features like block cloning, those kind of things, Microsoft recommends REFS, which is Resilient File System, which is a new file system that they have it from 2019. So you can use REFS for the volumes. And that's how you create the volumes. And then to scale out, you simply add a new node. So you put a new node in your rack, connect it to the top of the rack switch, 25 gigabit switch, and then you run this add cluster node, the new server name, and that's it. Microsoft will automatically assemble the server along with internal disk into the thing, and you don't have to do anything. Okay, so we have created a deployment guide for this. So this is free to download. I have given the link. So this captures all the detailed steps right from opening up the box, installing your adapter, installing your drives, everything from end to end, all the way up to installing and enabling the storage spaces direct. So it's captured in this guide here. It's a free copy. You can download from that link. Yeah, so that's all I had. So any questions if you guys have? I have some backup slides as well where I can go and talk in detail about two-way mirroring, three-way mirroring, and other stuff if you want. Yes. I mean, because there is this hash calculation that happens when every block of data comes as pages. So you compute and hash, and you look at your table, have I seen this block earlier? And if you have seen it, you simply increment the count. But if you have not seen it, then you write that. How many nodes? Okay, so in a two-way mirror, of course, it's an entire copies on the other node, so it can survive one thing. On a three-way, of course, on a nested thing, so this is a nested one. So here, you keep, this is what I said, on a two-way mirror, but then an exact copy is kept on other server as well. So it's like a RAID 1 within the node and RAID 1 at the cluster level. The next version is like RAID 5 within the node level, whereas RAID 1 at the cluster level. So these kind of things can survive one node failure and one disk failure on the other node, on the surviving node. Yeah. Yeah. Yeah, it supports, Ralph can probably answer the question better, he's our Microsoft guy, but yes, it has encryption of data at rest. BitLocker? Yeah.
Is it on? Okay. Hey guys, yes, that would be BitLocker at rest, and there's also encryption between VMs, so the VMs itself running, and I think Microsoft is working on enable encryption at runtime as well. Between those nodes, the traffic is encrypted as well. And by the way, if you got a headache after yesterday's party with the PowerShell command lines, how to build up a storage spaces direct cluster and settings, I recommend you memorize just a 3-word acronym called WAC, or Windows Admin Center. It's a free download. Yes, Microsoft has free things. Go to Microsoft.com, look for Windows Admin Center. That's moving forward the server management graphical user interface that's now separated out from Windows Server. So any new feature in Windows Server doesn't have a local management UI. It's all PowerShell. And if that's too complicated for you and you just don't care that much about command line, go WAC, install it. It's browser-based on a server or a PC in your domain network, point it to the servers. It will discover those. It has a beautifully simple and efficient functionality specifically for storage spaces direct, like enabling deduplication and compression for volumes, right, is as simple as a slider, like click, slide, done, right? That's simple. And setting up a storage spaces direct system, a cluster, setting up a cluster Windows Server-based cluster to boot, right, is almost stupid simple in Windows Admin Center.
Yeah,
right?
it's like 15 minutes. Yeah. 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 Yes, yes. There is a block cloning, which is again deduplication. So, for example, REFS has a clone, REFS clone file system. So, which means that when you can, if you clone a VM, the cloning is extremely fast because you are going to, you are not going to exactly take a copy. Again, it will deduplicate with the reference count. So, your VM clone is going to be much, much faster. Okay, so I think probably the next, we're running out of time, looks like there. Yeah. Okay. Okay. Thank you.